Hello everybody and welcome back to more of the 2002 Grade 7 Gauss paper. We're up to question number 19. Hopefully you have managed to take a look at it for yourself, but if you haven't, let's look at it together. So question 19, what does that say? Oh, it's not an Anglo-Saxon name, so I'm going to butcher this, and I do apologize out there if this is your name. Subisha? Subisha? Subisha. Let's go with that. Somebody please correct me. Give me the proper phonetic pronunciation. Subisha wrote down Davina's phone number in her math binder. Later that day, while correcting her homework, Subisha accidentally erased the last two digits of the phone number, leaving 8934400. Okay, Subisha tries to call Davina by dialing phone numbers starting with 89344. So just probably started 4400, then 4401, 4402, and so on. What is the least number of phone calls she has to make to be guaranteed to reach Davina's house? Okay. So Subisha's got a lot of work ahead of her. Least number of phone calls. Okay. Well, pessimistically, I guess, what could be happening is she could be calling, 893-4400, then 893-4401, and keep going and keep going. And it turns out that Davina's phone number is actually 893-4499, so at the very end of that possible stretch. 00, 01, 02, 03, all the way up to 9899. Now, she doesn't have to go in that pattern. There's nothing that says she has to go in that pattern, but the idea here is she could be calling all the other numbers, and she might just have to call every single possible number that begins with 89344 until finally the last possible number, no matter what order she does it in, happens to be Davina's number. So that's what Subisha's up against here. So really, the question doesn't translate into how many numbers does she need to call to make sure she's guaranteed to reach Davina's house. It's now transmuted into how many phone numbers are there possible, starting with 89344, and then you have two blanks that you need to fill in. So how many ways can we fill in that blank? And that's a much better question to answer, rather than well, if she started doing every odd phone number, and no, that doesn't work. And you might be suckered into trying to do a strategy with this question. It's really not anything like that. There's no way that she could determine a proper pattern for anything like this, so it's really, she might have to call all the numbers. So how many numbers are there? And that's what this question boils down to. So, here we go. So the real question is, how many of these phone numbers are there? Okay. Well, the 89344 is fixed. And then we have two blanks that in no way relate to one another. This first one could be a 1, and this next one could be a 3, or a 5, or a 4, or it really doesn't matter. They're completely independent of one another. Now, they have to be single digits. So what could this one be? Well, it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one here, this last digit, well, it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay? So those are the possibilities. Now we have to combine them. We have to say, okay, well, how do we get 0, 0, and then 0, 1, and then 0, 2? So for each of the 10 possibilities for the first digit, so for each one of these first digits, we have 10 different second digits we can pair it up with. So to get the total number of possibilities, so the total number of possible phone numbers that start with 89344, we have 10 choices for the first digit and 10 choices for the second digit. We multiply them together to get the total number of possibilities. If you're unsure of this, if you haven't seen something like this before, try it out for yourself. So what I would recommend is you say, suppose you can only use 3 digits, 0, 1, and 2. Okay, how many possible last of 2 pairs of digits could you have? Well, you could have a 0, so the theory says, well, you have 3 choices for the first digit, 3 choices for the next digit, multiply them together and get 9. And so you can check that this theory sort of works out by actually writing them out for yourself. Now, you could write them out for this the 100 possibilities that we're going to get in this case just to verify it. But that's taking the long way around this. What we want to do is use counting techniques and mathematics to shorten this question. So for the smaller case, just to verify that multiplication does indeed give us the right answer, we could have 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. Okay. So that's 9 possibilities. And it's the exact same thing when you have 10 possibilities for the first one, 10 possibilities for the second one. We're going to be able to get a total answer by multiplying, and we get 100 possible phone numbers. Okay, so 100, is that one of the potential answers we could have here? Yes, it is. It's the very first one. So, the least number of phone calls she needs to make, well, she might just get every single phone number wrong. But to be guaranteed, she would in that situation have to have tried every single possible phone number. So, A, 100. Alright, let's flip the page in anticipation of the last question in Part B. Not the last question on the contest, mind you, but the last question in Part B, Question 20, which we're going to take a look at in the next video. So thank you guys so much for watching, and I'll see you next time.